Okay, we'll continue with the secrets, the dark side of AB watermarking. I looked for synonyms of explaining and I found elucidated. I'm not native English, so I also didn't know the word until I found it, so sorry about that. Yeah. So my name's Ronald. I run the product management for the watermarking suite of solutions that we have. The most prominent one and the most promoted one, the most preferred one from our side is AB watermarking. And that's what we will explain. I will also explain a little bit about why that is the preferred and the recommended solution. I brought with me my colleague Vladimir. He's my my principal system architect for the solution. So as a product manager, I have feature ideas, I speak with customers and so on, and then I go to Vladimir and say, hey, well, how about this and how about that? Could we adjust that in the product and could we add that to our roadmap and so on? So it's a little bit on how we have divided the roles. Maybe you've seen this already in the invite. So this is roughly what we're going to address in this talk. Of about 45 minutes. We have to keep an eye on the time to make sure we finish in time. And after, well, what is it? About, I think after question number 1, I'm going to hand over to Vladimir. And basically, after standardization and some other topics, I'll take it back and conclude where to picture this in other anti-piracy solutions or content protection solutions. And how to deploy it then, right? If you have decided to do it, how should you then deploy it in your workflow? So on the why and how of forensic watermarking, why in the first place would you want to have forensic watermarking, right? So there is a lot of activities ongoing in chasing piracy, and that most often results in so-called takedown requests. And depending on where the pirate content is being hosted, those takedown requests are being honored or not. And unfortunately, there are countries where those are never honored. And there are service providers, hosting providers, who follow those practices and also basically never honor them. So you may be efficient in getting things taken down, but pirates are very creative, may very soon have something up, but just to slightly change the URL and then they're back in business. And so you might want to know what is the actual source of this, which user identity is being used to leak the content, or which provider is responsible for leaking this, and then basically forensic watermarking comes into the picture, because that gives you the ability to trace back to what is the source. In its most simple form, we've depicted that on this slide. You distribute content which gets watermarked with a unique identity for every end user. Suppose you're chasing end users, then you would create a unique watermark which is for end user. That works, but that works only basically when you're able to do that on the client device, right? So in the client app, which you control as a service operator, you create the ability to either fetch a watermark from a server that somebody is hosting, like we would do, or you trust the device so much that you allow it to generate that watermark in the client itself, and then it gets overlaid on top of the video. Two, as we say, big disadvantages of such practices. One is that the content is still not watermarked, being delivered to the client device. And the second one is that it sometimes happens that the pirate doesn't use that app that you control, meaning he then gets access to non-watermarked content and may redistribute that, and then your forensic tooling doesn't work. And that's the very unfortunate situation, what you see quite a lot. I mean, to be honest, we do have a client solution, we sell it as well, but in general we see that people say, well, I think a server-side solution, an AB solution is too complex, takes me too much time to implement. My content provider tells me to use watermarking. I'm not so interested in piracy because I think it's anyway not happening with my distributions. So I take a client solution, I do a check in the box, and that's it. Well, that's a little unfortunate if you really are after the pirates, right? So why would you then need server-side watermarking, right? Why is it that we recommend to use a server-side solution instead of a client solution? And it has to be with what we also call the secured perimeter, right? Where, and especially this is valid for OTT, but also to a certain extent for broadcast, where does that secure perimeter end, right? And if I look at an OTT setup, then that secure perimeter ends after the CDN edge, because that is the part where basically you could trust all the interfaces, you can trust those servers, and so you want to make sure that this content leaves watermarked the secure perimeter, and that at the content consumption side, at the device, at the player side, that there cannot be messed with what hurts your forensic tools, basically. There's another reason to do this in this setup, and that is, well, very I would say it maybe in short depicted at the bottom of the slide, and that is a practice which is also being referred to as a collusion. So an advanced pirate might be aware that there is watermarking applied, which in normal circumstances leads to a single source, and then he starts to do something clever. He starts mixing those sources, because that might make the forensic tooling from his point of view impossible, or at least complicated. A client solution which is serving out a unique overlay to every single user, if that is being used in a collusion situation, averaging pixels, averaging frames, quickly switching between those, it's very hard to find those different colluders. Whereas if you use a server-side solution, and you will see shortly why, that is able to deal with collusion as well. Where a client-side collusion, there's only a few types of collusion which are very simple that you can fight with a client-side solution. So then, what is then AB watermarking that we promised you to explain today? Again, repeating here, serving a uniquely watermarked video from within your secure perimeter, that's basically not possible, right? Because then I break the CDN. CDNs are good at serving the same content to a big group of people, and if I ask a CDN to serve out a unique stream to everybody, it simply doesn't work, right? So you need something else. And so what you do is A/B switching per session based on something which is also being referred to as CDN tokenization if we look at the OTT setup. What does it mean? I've got a workflow, I input unmarked content, and I input it to something which is the embedder. And what does that embedder do? It creates two variants of that content. One which is watermarked with A's, and the other one which is watermarked with B. It doesn't mean that every single frame gets watermarked, right? You can be selective in that. Vladimir will also explain that different vendors of watermarking technologies follow different principles there. And another important thing is you need to make sure that you introduce CDN tokenization. You may already have done that because CDN tokenization is often a must for watermarking, but can be introduced also without watermarking because it makes your whole setup end-to-end more secure. So you need to make sure that each session gets a unique token served. And what you can then do once that unique token is in place is that at a location in your workflow, and usually that is the CDN edge, you do a watermark switcher which makes sure that you serve out a unique sequence of those A's and B's to every single user. So you only need 2 copies of the content to make a unique sequence to every single user. In the end, when there is piracy, you make a capture or you run a live stream in such a watermark detector, and that detector looks at that unique sequence and then tells you, if you're lucky, that this is the unique sequence that I found and it corresponds to this ID or this IP or this session or whatever you were tracing inside your CDN token that you did. Usually things are combined, CDN tokenization with that switching. It is CDN edge, and the most intense part of this is that integration into what is often being done in the encoder. So the watermark embedder takes some effort, is the most complex one here, We've done this with several CDNs, integrated those switchers. The big ones are all running our algorithm. It's not even code, it's some reference code that we provide. And we have seen a few CDNs implementing this in a couple of days. So that's an impression of the complexity. On to properties, domains, and standards.
Okay. Hello, everybody. I cannot speak as fast as my colleague. He is more, skilled in English than I am. So this looks very complex and demanding. And just to make it more interesting and make a detour, when I was growing up, I liked a lot of comics, but my favorite was Asterix from Uderzo and Goscinny. Yes, of course, Nicholas agrees there. And in Asterix, you have always situation that Asterix and Obelix try to save the world, and on the route to saving the world, they usually meet the pirates, and they crush the pirate ship, and then there is usually an old pirate who speaks Latin, and he says, non est ad astra mollis e terris via, which means there is no simple way to come to the stars from Earth. So things are very complex, and they are complex for us, and they are complex for our, let's say, peers. You can say competitors, but we see them as peers because we all have to do something different, because simply business is like that. But then we have also the same problem. And decisions around technology which is used in watermarking is something that drives our peculiarities. And in the end, we have to do it in the stack, which is video stack, and I had the freedom to do my interpretation of the video stack and listed it on the right-hand side. And it comes from a human visual model. There is some signal processing that you have to do, sometimes very serious. There is a raw video. There is a compression, formatting, segmenting, encryption, bandwidth, caching, screen, and then eventually there is integration. And all that we do has to do, will our watermark be visible or not? If it is visible, nobody is going to buy it or apply it. So that's what is called fidelity. If it is fidelity, if it is good, usually it's not opposite direction or inverse proportional, but robustness in general, when something is more visible, it means it is going to be less robust. So there is a trade-off. And then, in order to have sufficient data to trace something or someone, you must have some bits. These bits must be error correction protected, error recovery protected, which makes even more bits. These more bits need to put into the video pixels. This complicates again, and then we are, like a dog chasing our tail. You put more data, you make more noise, and eventually you make it more visible. Okay, let's make it less visible, etc., etc. So people do different ideas how to deal with that. And you can observe the problem in horizontal way. When I say content preparation, I mean encoding, of course. When I say content protection, I mean packaging and encryption in that sense. When I say content delivery, I mean CDNs, and then content consumptions, these are the players, decoders, devices. So you can try to deal it in horizontal way, you can try to do it in a vertical way, which means, okay, I'm going to invest in the features of the watermark. All of these makes a job of a technology and a product in domain of the watermarking very complex. So let's say we have some choices as owners or as people who produce something regarding the watermarking. When we embed the watermark, that's commonly in industry that's called pre-process the video. In Irdeto we say we embed the watermark. We can do it on a raw video, But we can also, you know, if we are some other competitor, we can do it on a compressed video. So this basically means that we end up in incompatibility with each other. And then you have to speak, for instance, with encoders, and they say, okay, but your competitor or your peer in the industry does it differently. Why don't you do it the same way? Of course, I cannot do it the same way. There are intellectual rights, so I cannot do it. I have to do it in my own way. And even if I do it in my own way in a raw video, you know, there are lots of math operations. People do it differently. Somebody spreads it in time. Somebody else does it on a frame, and et cetera, et cetera. So this already illustrates that in order to standardize such things, you have to make it like there has to be ear for compromises. Yeah. So this is just another picture about embedding. You can say, okay, why bother? I'm going to make watermark, but I'm going to create a side channel. So for the content coming, I'm going to identify my frames. I'm going to make a fingerprint of the content, and I'm going to share the fingerprint to the point where I need to detect it. That relaxes the watermark, but it complicates the detection because for every content you must have a repository of the fingerprints. You can do it the other way around. You can say, I spread my watermark to all of the frames, let's say in a raw video, but not necessarily. But I'm going to create the logs. These logs are not important for me to detect the watermark, but these logs are important for me to steer how the A/B is going to happen. So that's another way of doing it. Third way is going to be kind of like, okay, I want to be the most easy to integrate with. I am totally blind, and this is just a digression. There was in the slides before, you know, watermarks can be blind and informed. Informed, it means you put extra data to detector related to the content. Blind means that a detector just gets video, nothing else. So you say, I am going to just put a watermark, and whatever survives, survives. That's it. And that is very nice from the point of view of ease of integration, but the difficulty comes when detection comes. So that means you again go like a dog chasing your tail. As Ronald explained, there is step 1, step 2, step 3. This is essentially step 3. That's what we call switching. And actually the industry sometimes calls it encoding. I am kind of like encoding, but I see Nicholas shaking the head. So for us, switching means we have those variants. Variants are per a segment. Segment are essentially bits. When identity comes, the bit, each identity is a bit string essentially. Bit strings have that bit positions. Segments simulate these bit positions. So segments are indexing identities. You have 2 bits, A or B, but you have many bit positions. So what is good when it comes to standardization, all of us, regardless how we are competing with each other, we agree that kind of like from origin downwards, we do the same. Because it makes life easier for everybody, for them, for us, for partners, for everybody. So at least that's a good part. Of course, the switching happens in CDNs. Main property of CDN is to cache something, so to make it efficient. So you can see already from the perspective where it is in the stack, where the watermark appeared and where it actually becomes a part of something unique, that these are quite distances in terms of how we share the data in between. So this is just illustration of these 3 things that I mentioned. You can say, okay, I use some logs from encoding and I'm driving the edge with that maybe, or I'm using something from content and I'm driving my detector, or you can say, I'm not going to share anything. It's blind. And that's it. And when it comes to standards, luckily for us, we all came to some senses maybe, I don't know, 10 years ago. And we said, okay, but let's agree for the benefit of the industry, and let's make the standard such that encoders can do their job easier, such that packagers can do their job easier, such that CDNs can do the job easier, such that everybody can do it. So there are, in general, 2 standard bodies. Okay, Dash is part of SVTA right now, but at the time we started it was not. And strange enough, encoding API integration specs are done in UHDF, but since the specs were done, all the companies, including us, left because, you know, why would you be part of some standardization group if you did the work, wrote a document, and you know, the fee you have to pay, why to pay further? But joke aside, these 2 bodies regulate Ultra HD Forum, regulates, there is a spec, which is mentioned somewhere below, which regulates how you integrate watermarking library, what we call embedder, into encoders. And Dash regulates overall end-to-end system. So regulates the interfaces. So that means what are the interfaces when it comes to AB watermarking from encoder to origin, what are the interfaces between origin and CDN, or maybe in a proper direction between CDN and origin, and what are the interfaces between player and CDN. The last one is the easiest, it's just a token. So the idea is to have a token with a segment request. That's all that there is.
Hey Vladimir, just a precision. This work was done in the -IF context, but we are agnostic to format, meaning it was -IF, but it works with HLS. It's not a Dash specific thing. Now it's SVTA umbrella, so it's a better and more generic umbrella, but it's really an industry-wide proposal that we have here.
Thank you very much. Appreciate it. That's actually what he said is pretty much true. I'm just forgetting things. And yeah, why we are making a problem of something? Why we are making it so complex? And I thought how to draw this picture, and I know it looks very much gray and it spreads all over the screen, but essentially it is summary of what we said so far, or what I at least said so far, which is I embed a watermark. Depending on my technology, it is in compressed domain or it is in raw video. I have to use some methods even below the raw video related to signal processing and human visual model. And that's where the information of the watermark resides. And then on its way, the content gets formatted, segmented, encrypted. But there is no trace of what was the watermark. And of course, luckily there is no trace, because otherwise it will be misused. But in order to properly do AB watermarking, you need some information about what was the watermark. And why? Because content delivery system, or CDNs, they are not going to open these segments. They are not going to examine them. They're just going to receive URL in the request, and based on the URL, they have efficiently to give A or B for the given segment. So there must be some relation between the segment name and what encoder did 2 hops before that. And this just illustrates what is the gap. And this is actually what we call metadata. So how do you pass this metadata? That is the thing that still even today makes some discussions very live. And after many, many discussions, I think that the industry came to conclusion that there are 2 distinct ways to deal with the metadata. One is related to live under certain conditions, and In live, these certain conditions, so boundaries that you put, are linked to the segment durations and the pace how these segments are propagating. So ideally, in live, you will have so-called grid of segments. Each segment, for example, dash segment will be 2 seconds. And hopefully each HLS segment may be the same duration, but maybe it will be 4 seconds. So it will be sequence of 2, 2, 2, 2, 2, and sequence of 4, 4, 4, 4, 4. Or maybe they are equivalent in dash in HLS. So you have single encoding, and then everything rolls out with a monotonic pace. And if you do so, then you can marry what the encoder did as a master of this job, and then packager follows it, and then CDN trusts the packager, and from the names of the files recovers back what encoder did. What does it mean? Encoder can say, and then of course we borrowed from Elemental the ripped off, as somebody said, the acronym or the phrase epoch locking. So that means encoder uses the timestamp. It also publishes that timestamp in the stream, so it is in the bound. But the same timestamp is used to drive our library. So when watermark changes from segment to segment, the change is linked to that timestamp 1-to-1. And later on, packager reads the ingest stream, collects that timestamp, and based on that timestamp makes the names of the segments. And later on, when player fetches the segments, these segment names are published in the manifest. So when individual segment request comes, CDN looks into the name, it knows the segment duration, and reverses back the timestamp. And from the timestamp, it knows what watermark was embedded for the segment. Based on that, and based on token coming from the player, it says, okay, player had this token, this is the bit string, the segment gives me this bit position because of the timestamp. At this bit position, player's token gives me A, or it gives me B. And this is how the sequence is done. In that way, for live, you can have within one request everything resolved. But it has to be same segment duration, and all these rules have to be followed. So naming rules have to be very clear. When it comes to VOD, in general, discrete files VOD is one thing, but discrete files is not very popular method in reality. All big platforms, they use progressive monolithic MP4 files for publishing, which means that what player fetches are the byte ranges. Since player fetches the byte ranges, it's not related to time, equidistant in terms of the time in sense of segment duration makes no value. Actually, in VOD, most of the cases, because optimal encoding segments might not be even same fixed segment duration over the time. What happens is you fetch the sizes, and because you fetch the sizes, your logic from the previous case is broken. So you must have something which is like a dictionary or a lookup, and this is what we call sidecar. And sidecar is an array of pairs, which we kind of like in the standard call VM-pace info, but what it is, it says this range, this bit position of the watermark, this range, this bit position. And these ranges and these bit positions are common between A and B. What is different is that in one case you have A, in another case a B. But that gives you exactly the same value that epoch timestamp give you in the live case. So in VOD, you have literally that you cannot reach the stars from Earth easily, unfortunately. This is an illustration of how we try to be smart. This is what we call a sandbox. This is a proof that the standard can, for what byte range, achieve what is required. We basically made workarounds of existing components or existing systems without changing them. In ideal world, half, if not more than a half of these squares and rectangles will disappear. Why? Because, you know, your encoder, which is the leftmost part, will include alignment of the streams for the byte range. And, you know, two components here are just for formatting for ingest. And one component is about what is called equalization. So that means that we at the GOP level try to align A byte stream and B byte stream. Because of the watermark, encoder will treat with small differences in bits, A and B. Sometimes A will be slightly bigger, sometimes B will be slightly bigger, so you will have variations. So what you do, in order to have equivalent byte ranges between A and B, you inject some sort of stuffing. We decided to do it inside of encoded bit stream. The middle rectangle on top is what the packager does. The most important component except the packager, which is actually the most important, but is the sidecar generator. So we use this information, this metadata, to create so-called sidecar file, which is that lookup. And then after that is just sanitation and do whatever. As a result, you have 4 files. Actually, you have 3 files per representation and common manifest for all representations. Blue and red are A and B variant. So these are MP4 files or ISO BMFFs of the variants. The green, if I'm not mistaken, the color from here, I don't see really the color. The green one is the sidecar, because sidecar is linked to the byte ranges. Every representation will have its sidecar. We in the standardization decided, so all the competitors, partners decided that the CBOR is used, because then we save the space. It is per representation, and the yellow one is the manifest. And CDN, because not all of CDN have capability to do extra read out or extra external request, we used Lambda on Edge. And, you know, hopefully in the future some cheaper solutions than Lambda on Edge will do exactly the same. And this showed to be totally okay. There are some challenges, and more details about that are shown in our paper which we did for Mile High Video this year. And am I giving it back to you?
Thanks, Vladimir. And maybe one more remark about Vladimir's last slide. This shows complex. This was complex. But why did we do this? We did this because he was part of the standardization body, and Nicholas was part of the standardization body, and so we were very well informed about what would be that standard. And if you then want to show at a very early stage, whereas the other partners in the industry had not yet adopted that standard, that still you can do it, then you have to make something complex as this, right? If everything proceeds well as planned, then in the end, the box on the left side is just the encoder. And the box top right is just the packager, right? So that is also something you will see in my final slides about how to deploy AB watermarking. It won't be that complex as this, right? That's to ease your mind a little bit. So a little bit back to the other area, right? A little bit less technical. What is AB watermarking? Where to picture it in the landscape of anti-piracy tooling and so on. So if you look at content protection in general is a proactive tool. We think about conditional access in the broadcast environment. We think about digital rights management in the OTT environment. So in DRM we speak about fair play, play ready, wide vine. That is what is also being referred to as DRM. And we look at tools including also CDN tokenization that I addressed a little earlier. And what in general those tools do, what content protection does, is it enables your business model as a broadcaster or as an OTT operator, right? In broadcast, it means that you can have a pipe in which several channels and everybody receives that same pipe at home, but by using conditional access, you can give people access through a base subscription and people access who pay a little bit more to a plus subscription, right? That is what conditional access is for. It also means that it avoids that your business models are being broken, so that people cannot decide themselves that, hey, I'm going to get that free upgrade, I don't want to pay for it, right? Or maybe a little bit less, how would I say it, addressed nowadays, but still a problem for, like the Netflixes of the world, credential sharing, right? How many parallel user sessions can I have? That also has to do with content protection, if it's properly implemented and if it properly works well. And then in the end, of course, it's about trying to prevent content theft, which leads to piracy, right? But I think it's important to address that those things are not just for preventing piracy, right? They're also there to run your normal business model. Forensic watermarking, on the contrary, is a reactive tool, right? It's an after-the-fact tool, so that if something in the proactive area isn't working as you were planned to have it working, which unfortunately happens, then you can use forensic watermarking to trace it back. So it's a reactive tool. Sometimes it may have a proactive or preventive event, right? I was talking with one of our customers recently, and they said, hey, if we switch on watermarking on that channel, that specific pirate notices that watermarking is on, and they switch to a different source. So they don't steal the content anymore from us, but they steal it from somebody else. So, well, that's great, right? Because that's what you want, right? You want that it's no longer stolen from you. It's unfortunate that they find it from somebody else, but you have achieved your goal, right? Because that's basically what you want to do. Maybe you would want to have it on because then you can trace it back to that source, but in the end, it's about the content no longer being stolen. Right? That's basically it. Okay, ideally you would have wanted to prosecute that people maybe in the legal way, but yeah, I mean it's about the content no longer being stolen, right? So that's some discussion. There is another initiative, right? C2PA, Content for Coalition. We are a member, right? We didn't join from the start, but recently Irdeto joined as well. We don't see that so much as tooling or as a development for preventing or tackling piracy, right? I mean, it's more about generative AI, deepfakes, and so on. So to prove where was your content originating from. The way it's being implemented now also makes it something that can be circumvented. And so from that point of view, we don't see it as an anti-piracy tool. Last on this slide, which is also being referred to in the anti-piracy area, is monitoring, right? So you monitor, especially on live, but also on VOD, that where else is this content appearing where it shouldn't be. And that results in what I referred to earlier already in my introduction to takedown notices, which are not always respected. It may lead to search engine link removal, right? Google publishes them in their transparency report. And what also is done in the monitoring area are the meta rights manager and the YouTube content ID, right? So somebody is monitoring his own platform based on a source content, a fingerprint content, whether that content is being distributed. And then depending on, as a content owner, how you have configured that part, how you have configured Meta Rights Manager or YouTube Content ID, it may lead to that content being blocked. It may even lead to that content not being blocked but being monetized in your favor because it's your content, so all the ads are yours and no longer from somebody else. And it may lead to, in combination as well, to that content being tracked because it's interesting to see where else people are watching it, and then you can count the totals, basically. So that's where we see forensic watermarking in the sphere of other anti-piracy and other monitoring tooling. Then finally, 2 slides about then how to deploy forensic watermarking, and this shouldn't be a surprise, given what we already showed. So basically all AB watermarking providers have a software library, we call it a plugin, an SDK, which is made available to encoder vendors. They integrate it into their encoder, and from the moment that it's operational, that encoder spits out A and B. So yeah, sometimes it is an issue with density, because your density goes down, because it does I mean there is something with performance, and that encoder should also spit out in one way or another the so-called metadata that Vladimir addressed, right, and which is being standardized. Then if the packager also complies, that metadata is probably changed in format, in the way it's encoded, but it's being made available to the CDN, which of course gets to its availability HLS, CMUF, but now in A and a B variant. And that CDN also integrates some reference code, which then, based on what it reads in the CDN token, for every segment that is being requested, can decide, am I going to serve an A variant or a B variant, without manifest manipulation. So it's just replacement, right? You don't need to update manifest, because you also don't want to reveal that you're doing AB watermarking. This is live, and the VOD case isn't so much more complex. It's just a phased rollout of live, right? You do encoding and metadata creation first, and upon a play out, that is made available in an origin, which can be an S3 or anything, and then the CDN plays it out in basically the same way as would have been done if it were live. And this is how you then deploy forensic watermarking. Pretty easy, right? I mean, that complex diagram, forget about it. If you're interested, go to Mile High Video Denver website, right, which was an event in February, and find that paper, and then you will read a lot more about it. But better to forget, because it is as easy as it is depicted here. Any questions? Is there anything you wanted to know about watermarking that we didn't explain?
On the identification side, what's the how many segments, is it configurable, or is there a set number that you'd have to have? Because if you've only got A's and B's, if you have 1 million people watching, you're going to need 20 odd, and if you have 50 million, you need 26 odd. Just like, where do you draw that line, or is it something you can say, oh, I know this is a low volume, or I know this is a high volume. I'm going to have to wait until they've watched a minute or 2 minutes or 10 minutes of video before every combination has been created? Yeah,
clear question. It depends, of course, per vendor, right? And I can only explain how we are doing it. What we are doing is we give each unique user an AB pattern, which could be 512 bits, or 1024, or 2048 bits. And basically the length of that pattern in the end, if you do a lot of mathematics on it, it will tell you how many colluders you can in the end find with the total number of bits, right? Because the more sources are being mixed, the longer you need to have that AB pattern. What we also require from our customers is that they upload a list, a one-column database basically, of all the valid identities that they have put inside those CDN tokens. We can translate that list in, for every token value, for every what we call a watermark ID, an AB pattern. And what I then do during detection is that I do an educated guess, because I know which ones are valid. In reality, that means when I have found back around 25 to 30 of those A's or B's, I know who it is. So in the event that basically we get a perfect case and there's nothing lost, and I have 2 second segments, 30 times 2 is 1 minute. So in 1 minute I have the guy, right? I mean, in reality, watermark encoding and piracy distribution is lossy. So you won't find back all those watermarks that were embedded. We have some statistics, and then it's around 40% that you lose, 40–45%. So that 1 minute becomes 2 minutes. But still, after those 30 bits, I've gone back. And then the base of subscribers doesn't matter so much, right? Because it doubles with every bit. right? So if I've got, I don't know, 75 million with 25 bits, with 26 bits, I could cover already 150 million people, right? So the size of the distribution, so the amount of viewers of an event or the amount of subscribers of a service doesn't matter so much. In general, we say 30 bits, and then you should be okay.
So the duration that you need in detection, the dependency on the size of the database is logarithmic. And because it is logarithmic, that's why the size of the database has a low influence. The most influence has whether it is a single identity that you are against, or 2, or 3, or 4, because those dependencies are quadratic.
Do we have any other questions? All right, let me give the mic here. I'll start with you.
Yeah, so my example of 30 is assuming that there's only one identity used, right? I mean, the moment you use 2, it becomes more, of course. So then you need longer content.
2 quick questions. So the first question, how much is the cost of having to do 2 encodes prohibiting customers deploying this?
Yeah, again, that depends on a per encoder vendor, right? I don't sell encoding capacity and I don't sell encoders. I was in a company in this area today and they said, well, we don't charge anything extra if they introduce AB watermarking, but I do need to run it on a more powerful machine.
Yeah.
That's a choice, right? I mean, there's also people who run it on on-prem encoders and the density goes down, meaning they can sell extra encoders, right? So.
Okay. The second question is, so you're using epoch locking, so fixed segment sizes, so no DAI or CMAF only. Is that right? On where you would support it?
Yeah, and fixed segment sizes is basically say on a per event basis, right? So HLS, and we're about to reach an agreement in the standardization committee about having different segment sizes between HLS and DES, because that should be supported as well. The example from one of the slides, but that, yeah, within the event, it should be a set segment size. Apart from, say, Scotty out, Scotty in, right? Because then temporarily the packager could decide to either split or to join segments. Mm-hmm. Most of the technologies can survive that, can deal with that, as long as the recovery after an ad break is back to the original grid, right?
Okay.
Thanks. All right, we have time for one more question, and it's right here.
Hi, so I was wondering if you have like multiple users would collude to like, you know, get different watermarked versions and then they mix and match the segments. Would your watermarking process survive that? Like, do you have like enough redundancy in the thing to survive like a mix and match of the segments?
So your question is, if you have multiple colluders, will we see it? Will we notice it? Or did I misunderstand the question?
Yeah. So you have like a list of segments that like either A or B, but if multiple watermarked videos are mangled together, would that break the watermark?
No, because, well, okay. No, but. So, in general, it will not. And there is a small detour there, because we can now speak only about what we do. In our case, identities, the bit patterns are random. So they are truly random. So what we generate based on what we switch is truly random. That means losing these bits, guessing these bits, and everything about it is virtually difficult. Since there are only 2 choices, that means occasionally they may have diametral watermarks. This watermark, if merged, we speak about overlapping now, they will negate each other. But the chance over the next segment, the next segment, the next segment, that the same 2 guys have the same the opposite bits is very small. It has to do with that kind of, like, if it happened once, next time is by far less. And that means they will have the same watermark for that bit. So that means that when you do overlapping of the watermark, for AB watermark, eventually your pace of watermarks will be divided in the worst case by 2, which is not true, but I can assume that, let's say theoretically. But the other 2 that survive will give out the people. So AB watermarking, that's why it survives, the merging and overlapping, because you have only 2 choices. So this segment, 2 of us have the same watermark, we create the bias. Next segment, we may not. We lose the watermark. Next segment, we again create a bias, and so on and so forth. If there is 3 or more or whatever, this is even stronger. Basically, majority always wins. And by majority wins, and by this random distribution, simply the guys pop up. Keep in mind when we do scoring, the guys who don't match, they go down. So the regular users will go down and go around 0 with the scoring, and the guilty guys will pop up like grass after the rain. Is
Thank
okay?
you. Yeah.
All right, Nicola, you asked if there was a quick demo.
We could do it later. Is that okay? Then
Yeah.
I can prepare it. So.
Yeah, what we're thinking is we're going to break now for, I'm sure everyone wants to get up and stand up. We're going to take a 10-minute break. We're going to start on time, 8:15 or so, with our final talk, and then we'll have our handout. So enjoy your break.